Commander, let's light the sky. Training sharper drone pilots, learning how to fly. Mission ready mindset, safety leading every plan. Skills that build confidence from takeoff through the scan. Tune in at Sky Commander, come join the crew today. Learning smart, fly with purpose, level up your way. We see more, no sooner, that's the edge we're here to spread. See above, go beyond, get ahead.
Okay, let's get started.
Picture the scenario, right? You're standing out in this wide open industrial field.
Oh yeah, just perfect flying weather.
Exactly. The air is crisp. The sky is that, perfect uninterrupted blue. And sitting on the launch pad right in front of you is this high-tech, incredibly expensive heavy lift drone.
Heavily customized too, usually.
Right, exactly. And the client, so maybe it's a VP of engineering or, a lead site manager, they're standing right next to your shoulder, arms crossed, looking happy.
They're eager to get that data they've been waiting weeks for.
Yeah, they're ready. So the pilot, feeling the good energy of the morning, looks around at the crew, gives a quick thumbs up, and casually asks, "Everyone good?"
The famous last words.
Right. Everyone gives a subtle nod. The rotors spin up, the pitch changes, and the drone lifts off.
It feels like, a textbook start.
Yep, until it isn't.
Exactly. Because exactly 120 seconds later, the entire operational reality completely disintegrates. And, it rarely disintegrates with an immediate, fiery crash. It's usually a slow, agonizing, compounding unraveling of the entire plan.
A compounding unraveling. That's a great way to put it.
Yeah, it's the kind of chaos that builds just quietly enough that you don't even realize you're in a trap until the jaws are already closing.
That is the perfect way to describe it. Because in this specific scenario, the trap is a multi-front assault.
It always comes from multiple angles.
Right. So first, a low-flying helicopter suddenly crests the tree line.
Just out of nowhere.
Yeah, hugging the terrain because it's inspecting an adjacent utility corridor you didn't even think to worry about.
A classic oversight.
And at that exact same moment, an oblivious dog walker, staring at their phone, headphones in, wanders right past your cones.
Directly into the drop zone.
Directly into the designated emergency drop zone. And then, just to put the absolute cherry on top of this stress sundae, your happy client taps you on the shoulder.
Oh, here it comes.
They point to a secondary water tower that is completely outside of your authorized flight boundary and casually asks, "Hey, while we've got the bird in the air, can you just push out a little bit and grab that asset too?"
And suddenly, nobody is good.
Nobody is good. The airspace is compromised, the ground space is compromised, the mission scope is compromised. You are in a blender.
You really are. And if we, step back and look at the anatomy of that blender, the most terrifying and frankly the most fascinating aspect is that none of those events are inherently unpredictable.
Wait, you mean they're normal?
They are entirely mundane. Helicopters fly low in uncontrolled airspace near utility corridors all the time.
Right. That's literally their job.
Exactly. Dog walkers exist in almost every public or semi-public space on Earth, and clients, by their very nature, will always want just one more shot.
Because they're trying to maximize their budget, right?
Exactly. They're trying to get their money's worth. So these aren't like black swan events. These are the normal, everyday, ambient pressures of commercial field operations.
Which brings us to the core mission of our deep dive today. We're taking a microscope to this phenomenal set of training materials from Sky Commander.
Yeah, specifically Season 9C, Episode 25.
Right. Titled, The Mission Huddle, Precision Briefing for Drone Operations. And our goal today is to dissect exactly why those completely normal ambient pressures manage to utterly derail that operation we just talked about.
It's a huge issue in the industry.
It is. We're going to explore how a short, highly structured, repeatable pre-mission conversation fundamentally transforms abstract regulations into a rock-solid safety culture.
It really is a masterclass in applied human psychology and friction management, honestly.
So what's the central thesis here?
The central thesis we are exploring today is profound, but it's often ignored in the field. A commercial drone mission almost never fails because someone forgot to pack a spare propeller.
Right, or because they didn't have a laminated checklist in their Pelican case.
Exactly. It fails because everyone on the team walked onto the site assuming the exact same flawed premise.
Assuming the same thing.
Right. It fails because the quiet, creeping risks weren't forced out into the open air through vocalization.
They weren't spoken out loud.
Yeah. And worst of all, it fails because the first actual, genuine briefing the team conducts happens instinctively in a panic immediately after the first major surprise occurs.
Wow. After the first surprise. That's too late. So let's start by tearing apart that phrase, everyone good, because I hear this exact phrase used in so many different professional contexts.
Oh, everywhere. Boardrooms, construction sites.
Some sets. And it always feels like a psychological trap to me. It's an illusion of consensus.
It absolutely is.
When a pilot asks, everyone good, they aren't actually running a system check. They are asking a socially loaded question that practically demands an informity.
Yeah, nobody wants to be the one to say no.
Right. It's like a band starting a complex jazz piece without counting in or agreeing on the key.
Everyone just starts making noise.
Exactly. Everyone good does absolutely nothing to confirm where the invisible boundaries of the operation are. It doesn't assign specific sectors of visual responsibility.
And it certainly doesn't pre-program the cognitive triggers for an emergency abort.
Right. So why do we do it?
Well, the social dynamic of that phrase is incredibly dangerous. When you ask a group of people, everyone good, you are asking for blanket agreement without providing the specific granular data required for them to agree intelligently.
You're relying entirely on a vibe.
Exactly. And a vibe is not a measurable safety control.
Definitely not.
Human nature dictates that when faced with a vague, positive-leaning question like that, especially when the client is standing right there tapping their foot, people will nod.
Because the weather window is closing, right?
Yeah, the pressure is on. Nobody wants to be the primary source of friction. Nobody wants to be the person who raises their hand and says, actually, I'm not good. I don't fully understand where the southern boundary of our flight area ends.
Right. The social pressure to just nod along is overwhelming.
It really is.
So if the vibe is the enemy, we have to replace it with structural, unyielding verbal guardrails.
Yes, structural guardrails.
And the source material provides a very specific taxonomy for this. They break the pre-flight communication down into 3 distinct tiers.
Right, starting with the standard briefing.
Layer 1, the foundational layer. This is the mechanism that forces the crew to answer the question, are we genuinely operationally ready for this specific environment, or are we just excited to put the gear in the air?
And it's vital to recognize that a standard briefing isn't just a casual chat. It is a rigorous, consistent pre-mission download.
Yes, formal.
Very. It forces the team to cover the same core metrics every single time, without exception. The primary objective, the physical location constraints, the specific aircraft configuration.
Airspace classifications, micro-weather conditions.
Exactly. Assigned roles, identified hazards, emergency protocols, and the ultimate go or no-go criteria.
The text makes a brilliant comparison here, actually. It links it to a heavy civil construction crew's morning safety talk.
Oh, that's a great analogy.
Yeah, like the safety talk doesn't pour the concrete, and it doesn't operate the crane, but it serves as a critical verbal safety control input that physically stops the crew from stepping blindly into the momentum of the day.
It pauses the momentum.
Right. Then we step into the second tier, which the sources call a tailboard, and the text gives us this fantastic gritty memory hook for it.
Truck tailgate truth time.
Truck tailgate truth time. I love the imagery of that because it instantly grounds the concept in the physical reality of field work.
Yeah, the tailboard is a concept heavily borrowed from the utilities, forestry, and industrial sectors.
Okay.
It's a broader, more holistic site overview.
Yeah.
This is where you physically gather the entire crew, often literally standing around the tailgate of the primary work truck, and you establish the macro environment.
So it's not just about the drone.
Exactly. You aren't just talking about the aircraft here. You're pointing out the physical work area.
Yeah.
You are establishing where the vehicles will be parked so they don't block access roads.
Right. Practical stuff.
Yeah, confirming what personal protective equipment, or PPE, is required on this specific site. Discussing the client's facility access rules.
Where the muster point is in case of facility-wide alarm.
Identifying broad environmental hazards like active heavy machinery or high-voltage switchyards nearby. It basically sets the stage for your existence on the job site.
Which perfectly sets up the third tier and really the star of this entire deep dive.
The mission huddle.
The mission huddle. So if the tailboard is the broad macro-level site survival guide, the mission huddle is the highly compressed, intensely focused, aviation-specific team synchronization.
And it happens literally moments before the pilot arms the motors.
Moments before. It is the final, definitive firewall. It is the last clear, structured opportunity to catch a fatal assumption before kinetic energy is introduced into the environment.
Precisely. And this is where the Sky Commander materials highlight a massive operational misconception that plagues the industry.
What's the misconception?
Well, a lot of commercial operators, even seasoned ones, treat the briefing as if it's just reading a mechanical checklist out loud while everyone stands around waiting for GPS lock.
Just going through the motions.
Right. But there is a massive fundamental psychological difference between a checklist and a briefing.
Break that down for me.
So a checklist is designed to confirm physical tasks. Did we remove the gimbal cover? Are the props locked? Is the battery seated and clicked?
Right. A checklist verifies the machine.
Exactly. A briefing, conversely, is designed to build a shared mental model. It synchronizes the human operators.
I get the theory. I really do. But let's deal with the reality of commercial operations for a second. Let me push back on this a bit.
Sure, go ahead.
If I am running a 2-person crew, and my visual observer and I have been flying together for 4 years, we've mapped, 500 generic dirt lots. We've inspected 200 cell towers.
You know each other's rhythms perfectly.
Right. We know what we're doing. Making us stand there, look each other in the eye, and recite a rigid 90-second script about roles and emergencies feels incredibly performative.
It feels like a waste of time.
Yeah. At what point does this kind of forced procedure just become a bureaucratic distraction from simply looking at the sky and doing our jobs?
Yeah.
Isn't forcing a script on a veteran crew a bit insulting to their accumulated expertise?
That is the exact argument you hear from veterans across the aviation industry, not just in drones. We know what we're doing. Don't bog us down.
Exactly.
But the text counters this with one of the most vital insights in the entire training. Experienced crews actually require rigid scripts more than novices do.
Wait, more? That feels entirely counterintuitive.
Yeah.
Walk me through the mechanics of why a veteran needs a script more than a rookie.
It comes down to the neurology of experience. Experience naturally creates speed, and speed inevitably creates assumptions.
Okay, I'm tracking.
The human brain is essentially a predictive engine, right? It wants to save energy. When a novice walks onto a site, their brain is in high alert information gathering mode because everything is new to them.
They're taking it all in.
Right. But when you've mapped your 500th dirt lot, your brain doesn't want to process the raw data of the environment anymore. It wants to rely on the pattern.
I see. So you automatically assume the airspace above the lot is clear because it was clear the last 499 times.
Exactly. You assume the client isn't going to ask for a dangerous mid-flight change because they haven't in the past. Your brain literally stops seeing the unique reality of this specific flight and instead overlays the memory of the past safe flights.
That makes so much sense.
So the script does not replace your expert judgment. What the script does is serve as a cognitive circuit breaker.
A circuit breaker.
It forces your brain to snap out of its predictive loop, slow down, and consciously acknowledge the friction and the reality of the environment you are standing in right now.
It protects your expert judgment from its own efficiency.
Exactly. Beautifully said.
That is a phenomenal way to frame it. Complacency isn't just a bad attitude, it is a biological function of the brain trying to save energy.
And the script forces the brain to spend that energy.
Okay, so we've established why the huddle is biologically and operationally necessary. Now we need to define the architecture of the operation itself before we can brief it. We need to define the cast of characters and the boundaries of our operational reality.
And that starts at the absolute top of the hierarchy with the pilot.
Right.
The terminology shifts slightly depending on whether you are operating under the jurisdiction of the United States FAA or Transport Canada, but the crushing weight of the responsibility is identical.
So in the U.S., operating under 14 CFR Part 107 constraints, the pilot is formally designated as the Remote Pilot in Command, or the RPIC.
Correct.
And the memory hook provided in the materials is great. Responsible person in control. It's not just about who has the sticks in their hands. It's about who holds the legal liability. They are the legal captain of the ship.
Exactly. The RPIC holds final, unyielding authority over the entire small UAS operation.
Air in Canada.
In Canada, under the Canadian Aviation Regulations, the CARS, the term is simply Pilot in Command, or PIC. But stripping away the acronyms, the plain English reality for both jurisdictions is this. The pilot is the single individual who absolutely owns the launch decision.
And more importantly, they own the landing decision.
Yes, they are the ultimate accountable entity. If the drone hits a car, the federal investigator doesn't care what the client wanted, and they don't care what the VO suggested. They look at the PIC.
Which brings us to the visual observer, the VO. And here is an observation from spending time around commercial sets. It seems like a vast majority of the industry fundamentally misunderstand what a VO is.
Oh, massively.
They treat the VO like a human camera tripod with a pulse.
Yes.
They tell an intern or a junior crew member, hey, stand by that tree and stare at the drone so I don't back it into a branch. They treat them as a completely passive spectator.
And treating a VO as a passive spectator is one of the fastest ways to invite a catastrophic failure.
Right. So how should we look at it?
The materials provide a memory hook that completely redefines the role. VO equals voice outside.
Voice outside.
A visual observer is not there to passively watch a screen or silently admire the aircraft. They are an active, vital, integrated safety sensor, but, a sensor is utterly useless if it doesn't transmit data.
Voice outside. That completely changes the posture of the role. It demands vocalization. It demands that they disrupt the silence.
They are legally obligated to disrupt it. If you look at the regulations, both Transport Canada and the US FAA, specifically 14 CFR 107.33, they explicitly demand effective, reliable, and timely communication from the visual observer.
Timely communication.
Yes. The VO's entire purpose is to constantly scan the optical horizon, detect conflicting manned air traffic, identify surface hazards, track encroaching people, and push that data to the pilot immediately.
So if your VO is just standing there with their hands in their pockets, silently watching the drone hover.
They aren't just being unhelpful, they are actively failing their federal regulatory duty.
Wow. Okay, that leads us to a really uncomfortable but incredibly common field scenario. Who exactly counts as a crew member?
This is a big one.
Let's go back to that client from our opening trap, the VP of Engineering. They hired you. They are signing the 5-figure check for the data. They are standing right next to you, looking over your shoulder at the telemetry monitor. Are they considered crew?
This is perhaps the most common and legally perilous trap for commercial operators. The fast, definitive answer is no.
No, even though they're paying for it.
The client standing next to you is absolutely not automatically a crew member. To legally be considered a direct participant in the U.S. or a person involved in the operation in Canada, an individual must meet 3 incredibly strict, unbending criteria.
And there's an acronym for this, right?
Yes. The acronym they use is BNC. Briefed, needed, and controlled.
Briefed, needed, controlled. That does not sound like a casual client visit.
It's the exact opposite of casual. First, briefed. Have they been explicitly trained on the specific operational risks, the emergency procedures, and the specific hazards of this flight?
Usually no.
Right. Second, needed. Do they possess a specific assigned safety role that is absolutely necessary for the safe execution of the flight? Are they acting as a VO?
Again, usually no.
And third, controlled. Are they under the strict, uncompromising operational command of the PIC? If the PIC says move, do they move instantly without arguing?
Definitely no.
If the client fails even one of those 3 criteria, if they are just there to look at the pretty pictures on the monitor, they do not count as crew. Legally, you must treat the CEO of the company paying you exactly the same way you would treat an uninvolved civilian walking a golden retriever through the park.
Treat the CEO like a dog walker.
Exactly, they are the public.
That is a staggering operational distinction. You cannot artificially wave away your legal safety buffers or your standoff distances just because the person standing inside the danger zone happens to hold the purse strings.
You have to have the professional fortitude to tell the client to step back behind the line.
Okay, so we've established the crew versus the public. Now we have to define the physical geometry of where this operation is taking place. The sources refer to this as the operational volume.
Yes, the operational volume. I like to visualize it as an invisible 3-dimensional bubble.
A bubble. Okay.
It is the absolute maximum spatial boundary where the drone operation is intended and authorized to occur. And crucially, it is not just the planned flight path.
What else is in the bubble?
The operational volume includes the maximum authorized altitude, the lateral contingency space required if the drone drifts, and the specific approach and departure corridors for the landing and recovery zones.
And you can't build that bubble without conducting a thorough site survey. And the memory hook here is brilliant in its simplicity. See the trap before the trap sees you.
The site survey is the bedrock of proactive risk management. You are interrogating the environment before you enter it. In Canada, CIR 901.27 explicitly requires the PIC to systematically determine that the intended operational volume is suitable.
Meaning you have to look at the airspace, the proximity to aerodromes.
Yes. Physical obstacles like buildings and terrain, the micro-weather patterns, and the density of people on the ground.
And in the U.S.?
In the U.S., 14 CFR 107.49 requires a virtually identical pre-flight assessment of the operating environment. You are hunting for variables: weather anomalies, airspace restrictions, ground property risks, and human traffic patterns.
All right, so let's synthesize this. We have our legally defined crew, we have isolated the uninvolved public, and we have mentally constructed our 3D operational volume.
We have the theoretical components.
Right, but how do we actually architect this mission huddle conversation so it doesn't devolve into a rambling 10-minute tangent?
Yeah.
How do we structure it so it cuts through the noise, the fatigue, and the pressure of the field?
The Sky Commander Training Manual approaches this with a really structural elegance. They assert that every single huddle, regardless of whether you are inspecting a massive industrial refinery or just taking real estate photos of a suburban house, must systematically stack 3 foundational conceptual layers.
3 layers. What are they?
The mission, the risk, and the response.
Let's pull those layers apart. Layer 1, the mission. Stripped of all the technical jargon, what is the core objective we are trying to achieve right now?
Right.
Layer 2, the risk. What are the specific kinetic, environmental, or systemic factors that could hurt us, destroy our equipment, injure the public, or corrupt our data?
Exactly.
And layer 3, the response. When the risk materializes, who is explicitly authorized to say what? Who executes what physical action, and what specific criteria immediately terminates the flight?
And, you know, it isn't merely about ticking those 3 layers off a list. The sequence of the conversation is paramount. The text introduces a concept called the mission huddle funnel. You must force the conversation from the macro-environmental constraints down to the micro-operational details. The mandated sequences: objective, airspace, site, people, aircraft roles, communications, emergencies, and finally, the ultimate go-no-go decision.
I love the logic of the funnel. It structurally prevents a crew from getting bogged down in irrelevant minutia before the massive existential questions are answered.
Oh, absolutely.
You absolutely do not start debating camera ISO settings or gimbal pitch speed before you have definitively confirmed that you have legal authorization to unlock the airspace.
Yeah, that happens all the time.
You don't discuss battery cycles if nobody has bothered to designate a sterile emergency landing zone. The funnel forces prioritization.
Exactly. Discussing micro details out of sequence creates a dangerous illusion of preparedness. You feel like you are being professional because you are talking about drone settings, but you are ignoring the macro risks.
So how do we make sure we move through the funnel correctly?
To ensure a crew aggressively moves through that funnel, the training architects the briefing around 7 mandatory questions that every single huddle must definitively answer out loud.
Okay, let's dig deep into these 7 questions because this is the meat of the protocol. Question 1, what are we doing? The absolute rule here is that the pilot must state the mission objective in one single concise sentence.
1 sentence, no rambling.
Why the strict limitation? It's designed to ruthlessly prevent mission creep. If your stated, agreed-upon mission is, we are capturing nadir imagery of the roof structures on buildings 4 through 7, it becomes infinitely harder for a client to sneak in a mid-flight request to, hey, just pan over and grab a quick video of Building 9.
Right, you've drawn a verbal boundary around the scope of work. You've established the contract for that specific flight.
Which brings us to question 2. Where are we allowed to fly? The text drops a massive warning here. It explicitly states that a pilot casually looking up at the sky, squinting and saying, well, it looks empty today, is not an airspace review.
Not even close.
You must verbally confirm the technical reality. What is the airspace class? What is our hard altitude ceiling? Are there any active NOTAMs? Are there specific landowners or facility restrictions we agreed to?
Yeah, question 3 is, what can hurt us today? This is the hazard identification phase. You name the wind shear, the road traffic, the magnetic interference from the steel structures.
And this is where the text introduces one of the most profound, fascinating insights in the entire curriculum. It specifically calls out the danger of utility wires.
Oh, this part is brilliant.
It says wires are exponentially more dangerous than trees or buildings because wires actively visually hide from the human eye.
It is a terrifying biological vulnerability. It's an optical illusion that kills pilots. The human eye and brain evolved to detect movement like a predator or distinct high-contrast shapes like prey.
We didn't evolve for power lines.
We simply did not evolve to detect perfectly straight, millimeter-thin lines suspended motionless in midair. Depending on the focal length of the human eye and the background contrast, a high-voltage line or a guy wire can completely disappear.
like against a backdrop of bare winter trees.
Or an overcast gray sky, a snowy hillside, or the glare of a low sun angle. The training is adamant on this point. If your operational volume involves any kind of utilities or towers, you must brief the crew under the assumption that the wires are actively trying to camouflage themselves. Because optically they are.
That's actually terrifying.
If the pilot does not explicitly say the word wires out loud during the huddle, the brain's reticular activating system will not prioritize hunting for that specific visual pattern, and the pilot will literally fail to see the wire until the drone is already wrapped around it.
That is absolutely chilling, and it perfectly validates why we can't just rely on experience to keep us safe. Our biology works against us.
It really does.
Okay, question 4. Who is doing what? This is where you destroy the bystander effect. You assign roles by specific names. You never say, hey, somebody keep an eye on the access road.
Because somebody is nobody.
Exactly. You say, David, you are the primary VO. You absolutely own the northern airspace sector and the primary access trail. Do you have the trail? Accountability must be binary and specific.
Which flows seamlessly into question 5. What words will we use? This is the standardization of communication. The psychological reality of an emergency is that as your adrenaline spikes, your cognitive capacity plummets. Your working memory shrinks.
You lose your vocabulary.
Yeah. In the middle of a flyaway or a near miss with a helicopter, you physically do not have the cognitive bandwidth to invent new vocabulary. You must rely on pre-programmed, universally understood commands like hold, land, abort, traffic, or lost link.
The text notes, with a bit of dark humor that yelling, or screaming, watch it, are not recognized emergency procedures.
I mean, it sounds funny in a studio, but I can vividly picture the panic of a drone drifting rapidly toward a crane and a VO just pointing and screaming, watch it, watch out for the thing.
And the pilot just completely freezing, staring at the telemetry because they have no idea what it is, where it is, or what specific kinetic action they're supposed to take to avoid it. The lack of vocabulary creates paralysis.
Exactly.
Okay, question 6. What stops the flight? You need explicit objective triggers. If the sustained wind exceeds 15 knots, we stop. If an uninvolved pedestrian breaches the 30-foot safety buffer, we stop. If the battery cell voltage drops below 3.6 volts, we stop.
You pre-decide the abort criteria when you are calm, so you don't have to debate them when you are stressed.
And that leads to the final critical point, question 7. What is the emergency plan? This is where you cement your contingency responses. What is the exact protocol for a lost command and control link? What is the procedure for a catastrophic flyaway?
Where physically are your primary and secondary emergency ditch zones?
Right.
The fundamental operational truth here is unforgiving. During a catastrophic system failure, gravity will not grant you the time to look around and debate where a safe place to cry might be.
Gravity doesn't wait.
The decision must be made, agreed upon, and visualized before the aircraft ever leaves the ground. Pre-decisions are the only things that survive a crisis.
So if you take those 7 questions and distill them down to their absolute essence, you get what the text calls the 90-second script. It's incredibly tight, almost militaristic in its rhythm.
Let's hear it.
Team, our mission is X at location Y. We are flying this specific aircraft within this specific 3D boundary. Airspace is Class G, weather is clear but gusty. Primary hazards are the guy wires on the north side. Roles are assigned, Jamie is VO. Standard calls are active, go, no, go. I will only arm the motors if every single person individually confirms they are ready.
And it ends by forcing a binary response.
Right. You can't just nod. Every individual has to vocalize ready or not ready.
That forced binary vocalization is the magic of the system. It shatters the illusion of consensus. It forces personal verbal commitment from every crew member.
And the materials go a step further, providing a brilliant adaptation for the reality of long days. They introduce the 30-second micro huddle.
Right, because you don't need to recite the full 90 seconds if you are just swapping a battery to resume the exact same mapping grid.
Right. The micro huddle centers around one incredibly powerful phrase, what changed?
What changed is arguably the most important 2-word question in aviation safety. As the incident reports consistently show, catastrophic mistakes rarely happen on the very first flight of the morning when the crew is hyper alert and slightly caffeinated.
They happen later.
Accidents happen on the 2nd, 3rd, or 4th flight of the day when the insidious creep of complacency has settled in. During that battery swap, the wind direction might have shifted 180 degrees.
The cloud cover might have dropped, changing the lighting on those hidden wires.
A new shift of workers might have arrived at the site. The micro-huddle forces the crew to actively interrogate the environment and prove that the baseline assumptions of the first flight are still valid.
Okay, so structurally, we've built the perfect operational bubble. We've got the script, we've got the funnel, we've got the standard calls. But as anyone who works in the field knows, the perfect plan on paper shatters the moment it collides with the messy, unpredictable reality of human ego, fatigue, and client demands.
It always does.
Let's transition into the case files provided in the Sky Commander sources and see how this plays out in the mud.
This is the crucible where theory meets actual practice. To truly dissect these case files, we must first deeply understand the specific psychological traps that snare even the most veteran operators.
What kind of traps?
We've talked about assumption drift and the dangers of task saturation, but there are two deeply ingrained psychological phenomena that routinely cause accidents: authority gradients and plan continuation bias.
Let's start with authority gradients. This is essentially the psychological friction created by social hierarchy, right?
Yes, exactly.
It's the scenario where a junior crew member, maybe a 22-year-old VO, fresh out of training, notices something inherently wrong, but they hesitate to speak up because the PIC is a 50-year-old veteran with 2,000 hours of flight time.
Right.
The junior VO thinks, well, the boss is an expert. They must see that helicopter coming. If I yell abort and I'm wrong, I'm going to look incredibly stupid and maybe get fired. So they stay silent.
Exactly. A steep authority gradient silences the safety sensors. It was a primary contributing factor in many of the worst commercial aviation disasters of the 20th century, where co-pilots literally watched captains fly perfectly good airplanes into the ground because they were too intimidated to take control.
That's terrifying. And what about plan continuation bias?
Plan continuation bias is equally insidious. It is the overwhelming psychological urge to push forward with a predetermined plan simply because you've already invested time, energy, and ego into starting it.
Even when the conditions change.
Even when the environmental data is clearly screaming that conditions have degraded, it's the deadly, we're almost done, let's just push through and finish it mentality.
Right.
A robust mission huddle isn't just about reading rules. It is a psychological tool designed specifically to flatten the authority gradient and dismantle continuation bias by making it socially acceptable and procedurally mandatory to stop.
That framing makes these case files so much more impactful.
Okay.
Let's examine case file 1, the low helicopter.
Okay, let's look at it.
You are executing a pipeline inspection in an uncontrolled airspace corridor. The airspace is legally clear, but you are utilizing a brand new junior visual observer. Suddenly, a helicopter appears low on the horizon. What is the specific mechanism that prevents a disaster here?
If the PIC conducted the huddle correctly, they wouldn't have just told the new VO to watch the drone. The pilot would have specifically briefed the systemic risk that manned helicopters actively utilize utility corridors for their own inspections.
They prime the VO's brain to look for that specific threat.
Crucially, the PIC flattens the authority gradient by explicitly handing the junior VO the standard call-out. Traffic north, low helicopter, moving south.
You give them the script.
The training underscores a vital reality. The VO is only a functional, reliable safety system if the pre-flight briefing explicitly empowered them with the exact vocabulary to use and the unconditional authority to interrupt the pilot without fear of reprimand.
That is brilliant. You are giving the junior crew member a script, so when they interrupt the boss, they aren't questioning the boss's authority. They are simply executing the protocol the boss ordered them to use. It removes the ego.
Exactly.
Let's move to case file 2, which I guarantee every freelance operator and commercial pilot listening to this has experienced. The client add-on trap.
Oh, this one's classic.
The drone is in the air, things are going perfectly, and the client leans in, points to a secondary structure way outside the brief boundary, and says, hey, can you just push over and grab that other structure real quick?
Those are historically three of the most dangerous words in aviation.
They really are.
They sound so innocuous, but they invite total systemic collapse.
The operational rule the sources provide here is pure gold. It should be tattooed on every pilot's arm. Good operators do not say yes in the air.
Never.
The mandated protocol is land, look, legal, launch.
This protocol is the ultimate defense mechanism against both plan continuation bias and acute client pressure. You do not attempt to recalculate risk while simultaneously piloting an aircraft.
So what do?
You bring the drone home and you land it. Then you look. You conduct a brand new site survey because that newly requested structure introduces entirely new geometry regarding roads, power lines, and human traffic.
Right. And legal.
Legal. You verify if your current airspace authorization actually covers that new geographic footprint. And finally, you lung, but only after conducting a new micro-huddle with the crew. Unbriefed ad hoc mission changes are the absolute root cause of sloppy, dangerous operations.
It takes immense professional courage to land the drone and make the client wait for 5 minutes while you run that protocol. But it is the only way to survive a long career.
It is.
Case file 3, public drift. You start a mapping mission in a completely empty, quiet suburban park.
Yeah.
But 20 minutes into the flight, the local dog walking group arrives, and suddenly civilians are meandering under your flight path.
This is where you must ruthlessly enforce your pre-briefed stop triggers. The instinct is to try and negotiate. The instinct is to hover and hope they walk away quickly.
But you can't.
You cannot argue with the public, and you cannot predict them. The uninvolved public does not know your safety plan, they do not know what a drone is capable of, and they do not care about your data collection schedule.
They're just walking their dogs.
Right. Therefore, you must engineer your operations around their normal, unpredictable behavior. If a civilian breaches the briefed safety buffer, your stop trigger is automatically activated. You halt the mission.
No exceptions.
No exceptions. You delay, you physically move the launch point, or you completely redesign the flight path. You do not compromise the buffer.
And case file 4, the controller handoff. This is highly specific, but incredibly dangerous. You have a complex mission requiring 2 pilots to share a single drone, passing control back and forth.
The unforgiving rule here is that you never, ever invent a control handoff protocol mid-flight. It must be explicitly briefed.
So how does it sound?
You utilize standardized closed-loop readbacks borrowed from manned aviation. Pilot A says, "You have control." Pilot B physically takes the sticks and responds, "I have control." Pilot A confirms. Confirmed, you have control.
Goes loop.
There cannot be even a fraction of a second in the timeline where both individuals mistakenly believe the other person is actively flying the aircraft. That ambiguity is where crashes happen.
So we've explored the psychology, the friction, and the behavioral protocols. But let's anchor all of this in the regulatory reality, because these aren't just best practices suggested by a training company. These behaviors are deeply tethered to the actual legal frameworks that govern the airspace. Let's look at how Transport Canada and the FAA view that exact moment of operational compromise.
Right. The regulations are the immutable legal bedrock that necessitate everything we've discussed. In Canada, CRR 901.23 is the absolute heavyweight regulation. It doesn't suggest, it demands.
What does it demand?
It states that normal and emergency procedures must formally exist, they must be actively reviewed by each and every crew member before launch, and they must be immediately physically available on site. You cannot just hold them in your head.
In the site survey.
Furthermore, CRR 901.27 is the legal mandate forcing the site survey we discussed, and CR 901.20 is the specific law that requires the reliable and timely communication from the visual observer. It is codified in federal law.
And when we look south to the U.S., the FAA's Part 107 rules are incredibly parallel in their underlying intent, even if the phrasing differs. 14 CFR 107.19 is the legal hammer that grants the RPIC final, unquestionable authority over the operation. 107.33 is the statute that mandates VO coordination, explicitly legally requiring them to scan for and communicate collision hazards. And 107.49 is the specific legal requirement demanding that thorough pre-flight assessment of weather, local airspace, people, and ground hazards.
The overriding practical takeaway from reading both sets of regulations is this. Both sovereign governments fundamentally expect the pilot to possess an intimate, verified knowledge of the operating environment, to assign crew roles without a shadow of ambiguity, and to operate strictly within established limitations.
It's the law.
Conducting a comprehensive mission huddle isn't just about looking professional for the client. It is the literal mechanism by which you achieve compliance with federal law.
Speaking of federal law and aviation in general, the drone industry is notorious for drowning operators in an absolute alphabet soup of acronyms. It can be overwhelming. Yeah. But the Sky Commander text provides some brilliant intuitive memory aids to help decode this language. Let's run through the critical ones. First, the core nomenclature, UAS versus RPAS.
This is a great distinction. UAS stands for Unmanned Aircraft System, which is the phrasing predominantly embedded in U.S. regulations. The memory aid provided is U.S. Aircraft System.
U.S. Aircraft System, got it. And RPAS.
RPAS, which is the terminology utilized in Canada and increasingly internationally, stands for Remotely Piloted Aircraft System. The memory aid here is vital for understanding the concept. Remote pilot aircraft signal.
Signal, that's the C2 link.
Exactly. It actively reminds the operator that the physical aircraft in the sky is merely one component. The pilot on the ground, the radio command and control link, the telemetry signal, they all constitute a single interdependent system. If the signal fails, the system fails.
Let's transition to the different classifications of operational sightlines, because this is where the industry is aggressively evolving right now.
Yeah.
We have VLOS, EVLOS, and BVLOS.
VLOS is the foundational baseline, visual line of sight. The memory aid is vision lets operators see. This is the strictest standard.
Meaning you literally have to see it.
If the pilot cannot physically see the drone's orientation and the surrounding airspace with their own unaided eyes, you have drifted outside standard VLS compliance.
What about EVLOS?
EVLOS is extended visual line of sight, the aid, extra vision, linked observer support. This involves a highly choreographed network of trained observers acting as daisy-chained visual sensors to extend the operational range.
And finally, the big one, BVLOS.
Beyond visual line of sight. The memory aid explains the complexity. Beyond vision, lots of systems. Because you cannot physically see the aircraft or the manned traffic around it, you must rely on a massive, redundant framework of detect and avoid technologies, radar data, and advanced certifications. You are trusting ones and zeros instead of photons hitting your retina.
And we also have to navigate airspace authorizations. In the U.S., we use LANC, Low Altitude Authorization and Notification Capability. The memory aid is perfect for the field. Low altitude approval, near current.
Near current is key there.
Right. And then there's the NOTAM, which stands for Notice to Air Missions. The memory aid forces you to ask the right question. Notice that affects mission. Did a VIP movement, a local air show, or a crane erection change the legal status of the airspace since you checked it last night?
Internalizing these definitions and their operational implications is incredibly vital right now because, as the text heavily emphasizes in its change tracking section, the regulatory landscape for the years 2025 and 2026 is undergoing tectonic shifts. The rules are rewriting themselves as the technology scales.
Let's dive deep into that shifting landscape. In Canada, they recently dropped a massive regulatory update with SOR 2025-70.
Yes, SOR 2025-70 was a monumental amendment officially registered in March 2025. It fundamentally rewired the Canadian framework by creating entirely new pilot and operator certification classes for lower-risk BVLOS flights.
Lower-risk BVLOS.
It massively expanded the parameters for EVLOS operations and introduced complex new regulations specifically governing medium-sized drones. These rules weren't activated overnight. They were rolled out in strict phases, with critical compliance dates hitting April 1st, 2025 and November 4th, 2025.
So what's the takeaway for the pilot standing in a field today?
The core operational lesson for any pilot reading this is that as we sit here in 2026, the sky is legally different than it was 2 years ago. Your pre-flight huddle absolutely must explicitly identify which specific rule, world, and certification class you are operating under for that exact flight.
And looking at the U.S., the FAA announced a highly anticipated proposed BVLOS rule back in August 2025. But the expert warning embedded in the training text regarding this is absolutely uncompromising.
It is.
It states that saying, "I heard the rules are changing," to a client or inspector is not a legal authorization.
I cannot emphasize the danger of that mindset enough. It is a massive liability trap. A notice of proposed rulemaking, or an NPRM, is merely a draft. It is not final, actionable operating authority.
It's just a proposal.
The industry gets so impatient for progress that operators read a press release about upcoming FAA changes and mentally start acting as if they already have BVLOS authority. They don't. Pilots must fly under the strict confines of the current published Part 107 rules, or they must possess explicit, highly specific waivers granted directly to them by the FAA.
You cannot launch a BVLOS flight on the promise of a future rule.
The huddle must aggressively answer the question, what specific current legal authority are we resting this flight upon today?
To ensure all of this intense regulatory, psychological, and operational theory actually translates into field-ready mechanics, the Sky Commander material provides an ultimate toolkit. They've engineered several critical memory aids designed specifically to standardize complex operations when cognitive bandwidth is maxed out. Let's review the emergency linguistics. First up, the HEDDLE acronym.
This is your comprehensive macro-level briefing structure. H stands for hazards, forcing you to name the wires, the people, the weather anomalies. U is understand the mission, clarifying the core objective and the strict boundaries.
Good. What's D?
D is duties, explicitly assigning who is the pilot in command, who is the VO, who is managing the payload. The second D is decision points, defining your objective go, no, go, abort triggers. L is lost link and emergencies, pre-programming the failure responses. And E is execute or exit, the final mandatory check where any individual on the crew can hit pause before launch.
For a more condensed operation, there's the BRIEF opening. Boundary, roles, issues, emergencies, final go, no, go. It hits all the same essential notes in a tighter package. But the one that I think is the most actionable, the one that should be actively running in the back of every pilot's mind during every single flight, is the LAND. Stop trigger acronym. You deploy this the exact second a mission begins to drift out of nominal parameters.
The LAND acronym is your psychological ripcord. L stands for lost awareness. If the VO loses visual track of the drone or the pilot loses situational awareness of the surrounding airspace, you abort.
Right, and
A is aircraft warning. If you receive an unexpected battery sag alert, a compass error, or a GPS degradation, you abort. N is new hazard. If a flock of birds enters the volume or the wind suddenly gusts beyond limits, you abort.
And D is different mission.
Exactly. Different mission. If the client suddenly asks you to fly over the highway instead of the empty lot, if any one of those single letters materializes in reality, you execute an immediate stop. You do not analyze it, you act on it.
And we touched on this earlier, but we need to reiterate the absolute necessity of the 3C call-out rule for visual observers. Clear, concise, confirmed. You do not chatter. You do not say, hey guys, I think there might be something flying over there by the big cloud. You state, traffic east, low altitude, moving west.
And the pilot must close the communication loop by confirming the data. Traffic acknowledged, holding altitude.
That disciplined communication style ties directly into understanding the profound difference between normal procedures and emergency procedures.
It really does. Normal procedure is what you execute when the day is behaving according to the plan. Emergency procedure is the rigid, pre-rehearsed script you execute when the day violently stops behaving. Under Canada's key RR 901.23, you cannot legally initiate a launch if a single crew member fails to understand their specific role in the relevant emergency procedure for a flyaway or a catastrophic command link loss.
It reminds me heavily of the commercial aviation concept of the sterile cockpit.
Right.
When an airliner is descending below 10,000 feet, the flight crew is legally forbidden from engaging in non-essential conversation. They can't talk about their weekend plans. They can only talk about flying the plane.
Right.
It's exactly like when you're driving a car in torrential rain and you're trying to merge onto a chaotic, fast-moving highway. What's the very first thing you instinctively do? You reach over, you turn the radio completely off. You desperately need quiet to process the overwhelming data of the critical phase. Critical phase requires a quiet space.
That is the perfect operational analogy. The entire purpose of the mission huddle is to proactively engineer the conditions for that sterile cockpit. It ensures that when the critical phase occurs, when the helicopter appears or the telemetry fails, the only words spoken on that job site are the clear, concise, confirmed words that you already agreed upon 10 minutes ago when you were calm. It eliminates the noise.
So as we pull all of these threads together, what does this ultimately mean for the listener? What is the final synthesized takeaway? A mission huddle is not a bureaucratic exercise designed to generate paperwork for a safety manager. It is not a tedious delay tactic keeping you from getting the job done.
Not at all.
It is the active, deliberate construction of shared operational awareness. It is the only mechanism that reliably stops a crew from stepping into the complex, kinetic reality of a job site blind. The greatest, most undeniable sign of a truly professional drone crew isn't the price tag of their heavy lift rig, and it isn't how fast they can unpack their Pelican cases.
No, it's not the gear.
The mark of a true professional is that they can look at an environment and name exactly what specific metrics will force them to abort the mission before the mission even begins.
A professional crew knows how to intentionally pause the momentum. They know how to humbly rebrief when the environment changes. And above all, they possess the professional fortitude to say no.
Which leaves you with a final provocative thought to mull over as you prepare for your next deployment. The Sky Commander text ends with a brilliant assertion. No-go is not a failure. It is professionalism arriving early.
I love that. Professionalism arriving early.
We live in an era where drones are becoming shockingly autonomous. The flight control software is getting smarter, the obstacle avoidance sensors are becoming incredibly dense, and it is so incredibly easy to just abdicate your safety responsibility to the technology.
People do it every day.
But the ultimate infallible safety feature on any commercial job site isn't the smart battery, it isn't the LiDAR array, and it isn't the return-to-home algorithm. It is the human capacity to communicate effectively under stress.
It's the humans.
It's the ability to recognize and resist the overwhelming social pressure from a client who is writing the checks. It is the absolute professional courage to look up at a perfectly blue sky, look at a happy crew, look at your state-of-the-art aircraft, and explicitly declare no-go when the unseen friction-filled facts of reality demand it. Because, as we saw vividly in our opening scenario, absolutely nobody wants to be the person just nodding along, relying on the vibe, when the oblivious dog walker and the low-flying helicopter decide to show up at exactly the same time.
That's a wrap on today's mission, Commander. See above, go beyond, get ahead. For more training, tools, and intel, head to skycommander.ca. If you learned something new, share it, subscribe, and leave us a 5-star debrief.